Hey guys, and welcome to another one of my videos. So in this video, I'm going to be going over what is inheritance and how you use it and why it's useful. And so I have a little example project set up here, and we are going to get into this, and I'm actually going to show you how it works and actually look at the blueprints. But before we do that, I think it's kind of important to go over some of the fundamentals. And in order to do that, I've set up a quick little presentation here, and I promise this is going to be worth your time. Um, it's not useless. I spent a good amount of time making this, and I tried to really only put in the really important stuff. So just bear with me. I know PowerPoints aren't the most exciting thing in the world, but I think it will be worth it. So what we're going to cover real quick is basically what is inheritance, what is casting, what overriding functions means, and the public, protected, and private accessors. Okay, so what inheritance is at a high level is basically it's just a hierarchy of classes. And by classes, we're also talking about blueprints because blueprints are classes. So if you look over here on the right, I just kind of have an example of some of the classes and some of the blueprints inside of Unreal. And then down here at the bottom, you can see I have food, apple, and cake, and those are ones that I've created. But I kind of wanted to show you a little snippet of one of the hierarchies inside of Unreal. So you can see the object up here, that is the base object for all classes inside of Unreal. So every class inside of Unreal, well, pretty much every class inside of Unreal, I should say, derives from object. So your actors, your cameras, your pawns, your characters, like guns that you make, like that all eventually inherits from object. So object is essentially the parent of all of those objects. So when you inherit from something, it's basically said to be your parent, and you are the child. So you can see the actor class is a child of object, and so object is the parent of actor. And there's also ones like widget and components and many other classes in the engine that inherit from object. But I've just shown a few here just to kind of give you an idea. And then these white ones that kind of go down the middle, this is the section I'm going to be specifically focusing on for this video. I just kind of wanted to add these other gray ones to show you that there are other ones. There's many other ones, even ones that are not on this graph, that are in this hierarchy. But obviously there's no reason to show all of them because it doesn't really matter. So one thing worth noting is that if you inherit from a class, you are considered to be that class. So for example, in this graph here, if you are a cake, then you can say that you are a food and you are also an object, because a cake, it is a food, but it is also an object. So when you inherit from something, a good way to think about it is saying, okay, I am that object type. And if you're inheriting from something and you say that sentence out loud and that sentence doesn't make sense. So for example, if you make a blueprint and you call it bullet, and that bullet inherits from the cow class, well, something's probably wrong, because your bullet is probably not supposed to be a cow. I mean, maybe it is, but you want that to make sense. So whenever you inherit from something, you're basically making a new type of that thing. So that's what it kind of means at a high level. And then casting kind of goes hand in hand with inheritance. So you can see I've just kind of broken out the main section of that hierarchy that I wanted to talk about. So whenever you have a reference to an object of any type, you can try casting it to a different type of class. So for example, you could cast to an actor, you can cast to a food, you can cast to an apple, you can cast to a cake. So whenever you make a new class, you'll be able to cast to it. But the cast isn't always just going to magically succeed, because the object that you're casting has to actually be in that hierarchy. So for example, let's say we have an object reference, and let's say that that object just so happens to be referencing a food. Well, if you try to cast it to an actor, for example, then it's going to succeed because a food is an actor. If you try to cast it to a food, then of course it's going to succeed because a food is a food. But if you try to cast it to an apple or a cake, it's not going to succeed, because a food is not necessarily an apple or a cake. And to kind of expand upon this more, so let's say you had a cake. If you tried to cast it to a cake, in that case, it would succeed. And of course, if you tried to cast it to a food or an actor, it would also succeed. But if you tried to cast it to an apple, it would fail. And another example, so if you had a camera, you tried to cast that to an actor, it will succeed because a camera is an actor. But obviously, if you tried to cast it to a food or a specific type of food, it's going to fail. All right, so the next thing I kind of want to talk about here is function overriding. So going back to our example here, let's say, so the food class is the one that I've created for this example. So let's say inside of the food class, we want our food to have a name. We want it to have a health restoration amount, so how much health it restores when you eat it. And we want to have a number of uses, because maybe you can eat it more than once or take more than one bites, basically. So when you add those variables to the food blueprint or to the food class, any blueprint or any class that inherits from that food class will also inherit those variables. So our apple will now have a name. It will also have a health restoration, and it will also have a number of uses. And so the cool thing about this is that even though you only added these variables to food, you can see inside of the food blueprint, you can set them to what you want, but you can also set them inside of the apple and inside of the cake. So even though there's only one name, for example, we can have the apple set the food's name to apple, and we can set the cake to cake, and we can change the restoration so that the apple restores 20 health, for example, and the cake only restores 10. And we can say the apple can only be used once, but the cake can be used 3 times. And you can set those variables to what you want. And so you can have different behavior for different types of classes or different types of blueprints, but it's all sharing the same variable. So you don't have to recreate that variable more than once. And then you can also do the same thing for functions. So for example, we could add a eat function to the food class or the food blueprint, and then the apple and the cake would kind of inherit that function as well. So what I mean by this is that, let's say you had a food reference, an apple reference, and a cake reference, and you had an eat function inside of food. Well, you could call that eat function off of the food reference, obviously, because he's the one that has the function, but you could also call it from children of him. So you could call it from the apple, and you could call it from the cake. And so if you called it from an apple, for example, it would just go up and it would call the eat function from the food. But you can also specifically, what do I have on my next slide? Yeah. So you can also specifically override these functions, and I'll show you exactly what I mean by that when we kind of go in and look at the blueprints. But let's say, for example, that you wanted all foods when eaten to restore a certain amount of health, whatever health they happen to have their health restoration set to. So, and you wanted that to be uniform across all foods. Well, you would put that inside of the eat function inside of the food class. But let's say for the cake, for example, you wanted him to also gain some stamina. So when he eats the cake, he gains some stamina and gains some health. Well, you could add the code to gain stamina inside of the cake's eat function, because you can override that function, and I'll show you how to do that in a second. And then you can just call the parent function. So the parent function is going to be food. And so it would first do whatever inside a cake's eat function, which is adding stamina, and then it would call the parent's eat function, which is food, and then food could add the health. And likewise for apple, I think the way I have it in the project is that when you eat the apple, it causes your character to jump, just as an example. So when you eat the apple, inside of the eat function of the apple, you can jump the character, and then you can call the parent's eat function, which will regain his health. And again, this will make more sense kind of once we get into it. I just wanted to kind of go through exactly what we were going to be doing before we started, so you'd have an idea. And then the last thing here to mention that's really important is the public, protected, and private accessors. So just to break it down real simply, public access means that it is accessible to anyone. Protected access means that it's accessible only by yourself and any child classes. And private means that it's accessible only by yourself. And again, I'll show you an example of this once we get into the blueprint, but just remember that for right now. So basically, when you start at public and you go down towards private, you're getting more and more restrictive in terms of who has access to either this variable or this function. And the golden rule here, at least my golden rule, is that you always want to prefer to use a more restrictive access as opposed to a less restrictive access, because you want to make sure that if somebody shouldn't be modifying a variable inside of your class, that they don't have access to it. So generally, if you're unsure, like, should I make this variable private or should I make this function private, just ask yourself, well, can it be private? And if it can be private because nobody else needs access to it, then by all means make it private. And if it can't, kind of ask yourself, can I make it protected? Like, who needs access to it? And if, all else fails, you can just make it public. And that's definitely, public is totally fine in a lot of cases. Like, many functions are public, obviously, because obviously you need access by anyone on several functions. And the last thing here worth noting is, so these public, protected, and private accessors can be assigned to either variables or functions. The only caveat is that variables cannot be set to protected. They can only either be public or private, and that's specifically to blueprints. If you're doing things in C++, you can make protected variables just fine because that's the way C++ works. But for whatever reason, I'm not sure why, for whatever reason, Unreal doesn't support protected variables. I'm sure there's a good reason for it. I just haven't really thought about it much or really looked into it, but you just can't do that for whatever reason. So with that being said, let's go back and take a look at the project here. So just like what we just talked about, I have it set up so that we have a food class down here. And if you hover over this, you can actually see that it says parent class of actor. It's like the third line down. It says the parent class is actor. And if you hover over cake, it says the parent class is my food class. And then on the apple, it says my parent class is the food class as well. So we have food, and then we have cake, which derives from food, and apple, which derives from food. So let's look at food, because that's the most important class here. Or actually, let me just run it real quick so you can kind of see what it does. So you can see I have a food object here, I have an apple object here, and I have a cake object here. And the way I have it set up is that when I look at an object and I press F on my keyboard, it's going to eat that object. So if I press F, you'll see it eats the food, and at the top left, it prints out health restored. So that functionality is all inside of the base food object. So the printing out the health and shrinking the object and then destroying it, all that logic is inside of the base food class. And so I have this apple food class, which it overrides that eat function, because when you eat the apple, the character also needs to jump. That's just an example here. You can make it do whatever you want, but I have it set up so that when you eat the apple, you jump, and then it also does everything else that the base does. So if you notice, when I press F, I jump, but it also prints out my health was restored, and it also shrinks the object just like before. And then the cake is set up very similarly to the apple, except instead of jumping, you regenerate shields. So if I press F, you'll see it prints out that my stamina was restored. Not shields. And that my health was restored. But you can see it didn't shrink and go away. And that's because the number of uses for the cake is set to something greater than 1. I think it's set to 3. So if I press it again, it's going to print it out. And if I press it again, then it goes away. And so that's because the number of uses for the cake is set to 3. So let me kind of show you how this works behind the scenes. So if we open up the food class, and remember, this is the base class. Let me just close everything so we can start fresh here. So this is the base class. And then over here on the left, we'll go through this one at a time to kind of show you how I have it set up. So let's look at the variables first. So what I like to do for blueprints, at least, is whenever I have a private variable, I like to add it to a private category. So if you don't know how to do that, basically all you do is you click on the variable, you come over here to the right, and you type in whatever you want the category to be named. And if it's a new category, it will add a new category to it. So I've just typed private right here. But the important part, because that doesn't actually do anything, that's just for organizations. The important part is this checkbox right here, this private checkbox. So that's how you change it between public and private. So if it's not checked, then it's public. If it's checked, then it's private. And again, like I said in the thing over here, there is no option for variables for protected, which is why it's just a checkbox for private and public. So the private variable over here is the remaining uses. Now, the reason why that is private is because no other child classes need access to how many uses are left, because all that logic is handled inside of the base class. It's not handled in the individual child classes. And I'll show you where we do that here in a little bit. But let's keep going through these variables right now. So constants, I didn't really talk about this in the PowerPoint, but this is also, it's not really necessarily connected to inheritance, but constants, I make this category, this is just another category that I created. I make this category whenever I set something to blueprint read only. And this is actually a really powerful checkbox here, because what this does is, just like it sounds like, it makes it so that the variable is read only. So that way you cannot set it. And you might be thinking, what's the use of a variable that can't be set? Well, what I mean by can't be set is that it can't be set after the game starts. So you can set it by clicking on it and setting it over here before the game starts. So you can set it to whatever you want, right? But after the game starts, you can't change it. And that's actually really powerful for things like constants. So you can see I have my 3 constants here inside of my food. I have the name, the health restoration, and the number of uses. So obviously we don't want the name of the food to change after the game starts. So we're going to set it to blueprint read only. We don't want to change how much health it restores, and we don't want to ever change the number of uses. And setting it to blueprint read only just kind of ensures that you can't accidentally change it in code, and it also kind of just helps you organize things. Because again, my golden rule is that you want to make things as restrictive as possible, um, not to make things harder on yourself, but it really, in the end, it makes things easier on yourself, because if things are restricted as possible, then it makes it harder for you to accidentally use them in the wrong way. And you can even see real quick, if I try to drag in like the food name, for example, and I try to set it, this is grayed out. I can't even set it because it's set to blueprint read only. Okay, and then so that's my variables. Components isn't anything worth mentioning because that's just the default stuff pretty much. And then over here I have functions. So you can see I have these separated into public, private, and protected categories as well. And again, these are just categories that I've created. You're not going to see these by default. So I've named it public, I've named it protected, and I've named it private. And then again, these are just categories. They're just for organization purposes. They don't actually do anything, just for visualization. The real thing that's important is the access specifier. And if you hit this on a function, you'll get access to public, protected, and private. So you can set it to whatever you want. And so I have 3 functions here. One set to private, the initialize, one set to protected, which is the force destroy, and one is set to eat, which is public. So I tried to come up with functions and reasons why we would want to have public, private, and protected, just to give you guys a good example. So let's start with this initialize one and why it's private and what that does. So you can see inside of my begin play of my food, I'm calling this private initialize function. And so the reason why I have this set to private is because this is the only spot that needs to call initialize. I would not want my apple to initialize because I want the food class to initialize. So basically this is private because nobody else needs access to it, and if somebody else were to call it, well, that would be pretty bad because it's already being called here in begin play. So since this is not being called from outside of the class, it's a perfect candidate to be marked as private. And then my force destroy, so this is marked as protected. So what this means, again, is protected. So I can call this, so if I drag this in, I can call this just fine. And it can also be called from my child classes. So if I go to cake, for example, I could easily call, if I right click, I can say force destroy, and it will pop up just fine, and I can call it just fine. And that's because it's set to protected. But again, if I tried to search for initialize, you see it will not show up. This is not it. This is just an event. So if I search again for initialize, there's no option here for me to call the initialize function inside of my food because it's set to private. And the reason it's set to protected here is because you might want to be able to allow foods to destroy themselves earlier than the remaining uses if they want to be able to do that for some reason. Like maybe you have a food that when you walk on top of it, you want it to destroy. Then you would need to have that function inside of the child classes so that they can destroy themselves if they need to. And then finally, you have the eat function. So this one is this one is public. And the reason it's public is because it is being called from outside of the class. So if we go to our character here and open him up, and remove these. So you can see, basically, I just have it set up real simply. When I press F, I do a line trace, and when I hit something, I cast it to a food and call eat. So this is really, there's a good amount of stuff going on here. So basically what it's doing is that when the line trace hits something, it's first casting it to a food. And what that does is that it's making sure that it's actually a food. Because if you remember, cast is either going to succeed or fail depending on if the thing is actually of that type or not. So if I'm looking at a cake and it gets to this cast and it tries to cast a cake to a food, well, obviously that's going to succeed just fine because a cake is a food. But if I'm looking at a wall or I'm looking at another player and it gets here and it tries to cast that thing to a food, it's going to fail. And so it's not even going to try to call eat. But the cool thing here is that it doesn't really matter what type of food I'm looking at. and it doesn't really even care what type of food I'm looking at. All it knows is that I'm looking at some type of food, and so just go ahead and call the eat function. So by default, it's just going to call the base class's eat function, which again is back here. And you can see what that does is it uses our little private variable, which again is why it's private, is because it's only used inside of the base class. We don't want anybody else modifying this variable, just us. And we just make sure that we have some uses left. And if we do, then we print out that our health was restored. And then we decrement the number of uses. And then we check if we are less than 1, number of uses left. And if we are, then we just call this little destroy timeline, which is in our event graph. And all it does is it scales down the actor and then destroys it. So that's the base functionality. But again, like I said, we have special functionality for our cake and for our apple. So let's go ahead and look at the cake real quick. So you can see this blueprint is basically entirely empty, right? There's nothing in here except for this eat function. And the way I overrode this, if you don't already know, is this little drop down button up here. So if you hit this, you'll see all available functions that you can override. And you don't see eat in here because I've already overwritten it, but if it wasn't overwritten, you'd see it in here and you could just click it. But it's worth noting that all these other functions are just functions that you can also override, but these are from different parents. So in this case, they're all from the actor parent. And this little text over here on the right is telling you which parent it's from. So you can see actor. There's actually some in here for food, so I can override some of the timeline stuff that does the scaling. I can override the initialize function that I wrote. And so if you had other parents that had functions that were available to be overridden, then they would also show up in this list. But we really only care about this eat, so let's go inside of here. So this calls the parent function. So the way this node works, if you don't have this node here, you can always get it back by right-clicking on the function and saying add call to parent function, and it'll show up. So what this node is doing is it's calling into the parent's version of that function. So the parent's version of eat is obviously our foods eat. So it runs all of this code. And then after that, it prints out stamina restored. And so that's why when you go up to the cake and you eat it, you can see it prints out that the health was restored and the stamina is restored. And likewise, if we go ahead and look at the apple, it does something very similar. It calls the parent function to do whatever it needs to do, and then it launches the character. So just as an example, if I were to take this out, so it's no longer being called and all I do is launch character, you'll see when I go up to the apple, all it does is jump me because I'm no longer executing the parent's code. So if you want to execute the parent code, then just call the parents function. And if you don't, which in some cases you don't, then you just don't call it. So it lets you have a lot of flexibility. And then the other thing I kind of wanted to point out is that protected function that I had. So if you remember back here in our food, we had this force destroy. So if I come over here and I say force destroy inside of my cake, you'll see now if I go up and I eat it, why did that not work? Force destroy. Oh, I never actually implemented this function. So we'll do some live coding real quick. So when you force destroy something, we just want to call our little timeline. So let me grab my timeline and we'll just say play from start. And let me try this again. So if I hit cake, you can see even though the cake has 3 uses, the child class over here has told it to force destroy, which is a protected function, so it's good for us to call. And it can destroy it and kind of override the functionality and do whatever it wants. So hopefully that kind of made sense. If you guys enjoyed the video, please leave a like and subscribe. I also have a Patreon if you want to support me. That's always appreciated. If you have any questions, I have a Discord channel in the description of this video. There'll be a link to it. Feel free to join and ask whatever questions you have. Otherwise, I'll see you guys in the next video.